Hello and welcome to this short intro video where I give you a quick overview of what space-time control is and how it works. Space-time control is a standalone application for macOS and Windows designed to control the Sillitoe Disk Mastering System, a modern cutting lathe for creating high-quality vinyl master cuts. Space-time control takes your digital audio masters and transforms them into a virtual groove, a detailed digital preview of the actual groove that will later be physically cut into the lacquer master disc. As the name Space-time control suggests, you have full control over all the various parameters that define the actual groove. To make an educated decision about these changes, space-time control helps you analyze the groove's geometry and its dynamic properties to fine-tune every aspect and get the most out of your cut. And when you're ready, space-time control sends the audio and control signals to the lathe, which then transforms all this information into a physical groove. But let's take it step by step. First, we need to add some audio to our track list. As an example, I've prepared side A of the iconic album Jazz at the Pawn Shop. This side has 3 tracks with a total runtime of almost 25 minutes. That's quite a challenge for vinyl. I'll just drag the folder with the WAV files into space-time control, and you can see it starts processing them right away in the background. At the top you can see the tracks section, where now the 3 tracks are listed. Expanding the list gives us a bit more detail about the digital level and some basic adjustment options. Once processing is done, we also get per track information about the groove, such as the average pitch or how much disk space each track consumes. Right now, with our default settings, we're only using about 70% of the available disk space in total, which gives us room to optimize the groove further. The main groove parameters are controlled by rotary switches up here. The most fundamental settings are disk diameter and playback or cutting speed. We'll stick to the standard 12-inch at 33 RPM for a regular LP album. If you're familiar with a Neumann VMS-80 lathe, the other settings on the right will already look familiar too. Basic width defines the width of the unmodulated groove. Min-land controls the land remaining between the groove. Lead-in time and marker time control the areas where you set down the needle on playback. There are more advanced options available in the settings dialog, but we'll leave all those at their defaults for now. What we will focus on in this short intro video are only the gain and elliptic filter settings. But before we adjust those, let's have a look at the lower half of the application window. Below the transport buttons and meters, you can see the waveform view of our 3 tracks laid out on a timeline. Just like in a DAW, you can move the playhead and hit the spacebar to listen from that point. I'll mute the audio to avoid copyright flagging on YouTube, but we'll let it play in the background. Space-time control is calibrated to the analog level of the lathe, so the levels shown on the meters here reflect what you get on playback from your cut if we send this to the cutter head now. Below the waveform, there is a graph area synced with the timeline. The array of radio buttons at the very bottom lets you choose which parameter is displayed in this graph. Right now it's showing the parameter disk level, so the bars illustrate how the peak level of our program changes over the duration of our cut. With the default gain, we're now sitting at around -6 dB, but for a typical LP we would prefer something closer to +6 dB. Let's increase the gain and bring us up to 0 dB on the gain dial. Now we're hitting +6 at a few points, great. And if you look at the disk usage now, we've gone from 70 to 90%. And to illustrate why that happened, let's look at the groove itself. By switching on the microscope view, we get a close look at the groove around the current playhead position. Let's bring the gain back down to where we started and watch what happens. As you can see, the lateral movement of the groove becomes much less. This allows the pitch algorithm to pack the groove more efficiently, thus reducing disk usage. We're now back at 70%. But of course, we want our cut as loud as possible without wasting disk space, so let's bring it back up. And let's try adding another 3 dB. Oops, now we're over the limit that can fit on our 12-inch record. Let's back it off by 1 dB. Perfect. We're using nearly all of the disk space available and reach a decent playback level for an LP album. Before we start cutting though, let's take a quick look at a few more important analysis parameters. I'll switch from disk level to stylus velocity. This blue graph now tells us how fast the cutter head needs to move the cutting stylus to cut the groove. And of course, the same velocity applies to the playback stylus when it tries to follow the groove. Stylus velocity is closely tied to playback level as well. If we would lower the level, the velocity would drop too. On the upper end there is no strict limit for velocity, but anything above 30 centimeters per second is worth a closer look. During cutting, high sustained velocity will heat up your cutter head's drive coils and might blow a fuse. And on playback, high velocity and therefore high acceleration of the stylus can create distortion or kick the stylus out of the groove. In our graph, big differences between the light and dark blue bars indicate strong high frequency content, like percussion cymbals or overtone heavy sounds. Since this is a live jazz recording, we can probably blame the drummer, so let's pick a region and zoom in. In the final track here, we can spot one of those high velocity sections. Zooming in, the microscope shows a bright streak with tightly packed modulations, a classic pattern of intense high frequencies. Let's play that part. Yes, it's a tambourine that causes our spikes in velocity. Even though the velocity peaks get close to 50 centimeters per second, the groove is relatively straight here, so playback should be fine. We might add some distortion to the tambourine, but skipping isn't a concern here. And since it's very short impulses, our cutter head should be fine as well. As a final exemplary parameter, let's also take a quick look at groove width. Whenever you have a different signal in the left and in the right channel, that's what we all call stereo, the groove isn't only moving laterally, but it's also changing its width with the signal, and that moves the needle up and down on playback. That's why cutting engineers always ask for mono bass to minimize this vertical modulation. Since we're working with a stereo live recording, the groove width is constantly changing, as our purple bars here tell us. The auto width control algorithm keeps the groove always above 30 micrometer. That's the lower limit for the groove width according to the standard. Whenever the groove would become too narrow, it is automatically widened by the algorithm to stay within the limit. The brighter pink bars show when this automation kicks in. Let's switch the automation off for a moment. Now the groove width occasionally drops to 0, which would definitely cause cutting and playback issues. Another way to fix this is an elliptic filter or elliptic EQ, which reduces the stereo bass content. But that's always a compromise, easier and safer cuts, but at the cost of less stereo low end. Now our vertical modulation is a bit more tamed and our groove width doesn't go to 0 anymore, but we still need to re-enable auto width to keep the groove above the required 30 micrometer minimum at all times. I'll end here with the analysis. I think you get an idea how space-time control works, and I'll let you play with the other parameters with your own audio program. In general, finding the right settings for your cut is always about finding the right balance between level, consumed space on disk, and the risk of playback issues. Space-time control is designed to help you find this balance for your cut and help you understand your audio material before actually cutting it. It deliberately is not designed to make any smart changes for you or override your mastering decisions. Except for the elliptic EQ and gain, of course, none of the parameters change anything about your audio master. Space-time control is meant to complement your mastering setup and not to replace it. And finally, after all the tweaking and analysis, cutting the project is as simple as pressing the record button. Make sure your lathe is connected and primed, just hit record again here and you're cutting. The meters will show what's happening in real time while your physical cut is in progress. And with this view, I'll thank you for watching. And if you have any questions or feedback, I'd love to hear from you. Happy cutting!